Hello everybody, welcome back to our making an engine from scratch stream. As always, let's start off with the most important question of the day. How has it been? How has your day been? How has your week been until now? How do you expect your week to continue going after this stream? Anyway, that's a long ass introduction just to say welcome to the stream. Plan for today, plain and simple. We're just gonna keep working on our game engine, focusing again on the render API because that's still not done, even though I expected it to be done already. But oh well, it's still there. I mean, I don't think it will be that much more work. Saying that, maybe if we clip this by the end of the stream, you'll see me like trying to pull my hair out, saying like this was a mistake. But none of that yet. We'll jump into the coding right away in a second here. Just give me a minute to check if everything is up and running. Just post some links here and there, do some of the typical stuff. Okay, so copy that one. There we go. Put it in here. Paste that. Oh, actually, I should actually share this for once. If you are interested in my content and keeping up to date with it in between streams, I also have a Discord. Not that I post there regularly, but first of all, you will get an announcement when I actually stream next. And well, secondly, you can ask me questions if you want to. But yeah, that is about it. If you want to find the link, that's an important question. It should be in the description. And if you can't find me, just yell in chat or something, and I'll see how it goes. But for now, I think that is all going up and running. So I think we can head over to this coding stream itself. Yeah, I think everything is up and running. That's good. Hello, welcome to the stream. I was just gonna transition. There we go. We're transitioned over to the coding side of things. Introduction is done. We'll start coding in a second. Let's first go over the game plan for this stream. First of all, I did make a note last stream that we can replace the DirectX 12 unique pointer with a new one. I'm not gonna do that. After I explain everything that we're gonna do today, or try to do today, I'll explain why that is not actually needed and would just complicate things needlessly. But we're gonna focus on the render API again. Gonna just start from scratch. Well, we're gonna make a class, a structure to hold our model data. Currently, we're just gonna specify it manually, but later on we can just load in files if we want to. But for now, we're gonna specify it manually, and then from there we're gonna see like, hey, okay, so data, what does it need? It needs indexes, it needs vertices. I'll explain all of that stuff later on. We need a material, so we'll make a material class, and so on and so on, and see how we actually want to structure the rendering side of the engine and try and abstract everything from DirectX 12 in here, so that when we actually want to switch over to another API, we can actually do it pretty easily. Okay, I think that's about it. That's the game plan. So, first off, why is having a separate DirectX pointer better than implementing it in our unique pointer? Well, first of all, I did implement my own unique pointer last stream, and it's by no means the best one out there. Not at all even, but it does have some interesting things here and there. I don't think we actually need this anymore, but that's nice. I do want to have one with a no pointer, I think. Maybe, we'll see. But yeah, that's about it. I think that's all fine. Actually, I think we can initialize it with a no pointer now. So actually try that. I don't know where I specified. Probably in the window, isn't it? Or in the base app. No, I checked base app. It's not in there, is it? No, there's nothing in here. But we do have our application class. Is it in here? Yeah, we have a unique pointer. So can I just do no pointer now without giving issues? Apparently not. Can I initialize with the no pointer T? Okay, so we need to make an overload for that. Let's do that first, because that will help so much more by actually showing that it's a no pointer. So let's just make a new one. I think we can just do no pointer type. And where is that defined? Oh, it's in namespace standard. Okay, let's no pointer type. There we go. Not implemented yet, but we can just implement it very easily as just saying this. Copy that, paste it in here, and just say standard no pointer type. Come on. No pointer. Oh my god, I'm typing in all the wrong places. That should work, and now we can actually implement it with a no pointer. So then if we do this, yeah, okay, that works, perfect. Okay, that's way better, great. Okay, so why is it a bad idea to implement? Basically, so let's go take a look. Let's pin this so we can explain it. Where's the pin? That's the pin. Let's find our DirectX 12 pointer as well, which is this one. Let's open it first, then pin you as well. It should point here. Okay, so now we have these side by side, right? Okay. This unique pointer has a type specifier, which is the type we want. The only thing it will do is call the destructor. Well, it will just say delete when we destroy it. That's the only thing it will do. It will manage the data inside it. Well, the memory inside it, I should say. The DirectX 12 unique pointers are a bit special. There's a special case because they will call release on the object if it has something inside. We can also make our normal unique pointer work with this kind of thing, but then we would need another. Oh my god, I pinned these for a reason. Okay, so then we would need like another type in here, which is like the deleter. First of all, that will make things way too complicated because I'll need to make sure that we can take any function, even lambdas and stuff like that. I will need to make it work with that, and so on and so on. And we can do that in the future. I don't want to implement it now. It's way too complicated. Well, I mean, way too complicated for now. Secondly, this is like the edge case. This is the only case I know where you would actually prefer having a specific delete function rather than just calling the keyword delete. So that's why I'm just going to keep it as a DirectX unique pointer separately from the normal unique pointer, so we actually know it's doing some specific calls. And if we want to specify it a bit different in the future and we do implement the deleter, then we can just make a using for it that says using unique pointer, or DirectX 12 unique pointer is whatever unique pointer we want in here, right? And that's also gonna work, but that's not what we're gonna do. We're just gonna leave it as it is today. So that was point one. I already deleted it. So now I think creating a basic model class would work. I'm not gonna specify or think too much about how I want to structure the model itself yet, I think. Hold on. Let's actually go look at the code behind it for now, which I think is all just in render API. Did that? Oh. Hello. Oh yeah, this one. So currently this is badly implemented because it has a link to DirectX 12. We want to hide that from our end user, which I already started working on, but it's not fully done yet. So you don't want any reference to DirectX 12 in here by the time we're done. So all of these will have to be separate types, which we already did for the window. The window is already obfuscated. This uses windows, but we don't see that here. We actually only see that in the implementation later on. So that's good. All of these will have to change eventually, but let's start with our model. Our model will just have a vertex buffer, I think, and an index buffer if I'm not messing up things, but I don't see it in here. So let's go take a look at. Do we have like a create resources function somewhere? We have an initialize, which will not to what I expected it to do. Frame resources, yeah, load assets. This is the one. This is the one that will load the vertex shader, the pixel shader in here, but it will also load our data, or at least I thought so. Where is a triangle? Is it further on even? Oh, here it is. This is a triangle. So this is what we're gonna try and mimic. This is what we're gonna try and hide away, right? So we're gonna make a model class, which will probably just have a vertex and an index buffer. I'm not sure. We will change that model class later on when we actually load files, because then we will specify it with what we need. But this is what we want, right? We would just want a list of vertices, for example. And these vertices, what is this? This is a custom thing, which just contains a position and a color. That's basically what we want. How I'm gonna do that? God knows. I mean, we can make all of these things very simple, but in the end, we'll need to map it. Where is it here? We need to map it to actual data, right? So we need to make sure that it has a proper layout, and then we can just mem copy it over and it's fine. But we'll need to specify all of this as well, which we'll do in probably the material, which will say like we have this kind of layout, and so on and so on. I'm not 100% sure how we would do it. But basically for now, I'm just gonna store at least positions. We at least need positions, which is these. And then maybe colors, so we can get the same kind of thing. But that's technically not needed. We can just do UV coordinates or something. That's also an option. But for now, I will keep a vertex. Just we'll make a specific vertex per. It's gonna be complicated, isn't it? How do we load models? Because normally, when you get an object file, you get an object file. Inside there, there's vertices, but there's also information per vertices, but that can differ depending on what we want. So for now, I think we're just gonna make a basic version of it. We're basically gonna copy this structure to a separate file. And we're gonna say this is the type of information we use at the moment, which will just be a vertex containing a position and a color. And we'll start from there. Eventually we can probably make our custom layouts and stuff like that, but for now let's keep it simple. We just want to get rid of this big giant file and split it up a bit. Okay, that being said, we need to make a vertex file. So to do that, first let's go take a look at the render API here. We have a couple structs here. The vertex, specifically rendering. A float 2, a float 3 and a float 4. It's technically not specifically for rendering. So what I'm gonna do is I'm gonna move these over to a separate module, which we already have, which is called corelib, which will just have a bunch of basic types. It will eventually also contain containers, stuff like that. For now, boop, that will be in there. Any tips on coding? You have to be more specific than that though. I do have a bunch of tips, but it depends. Or is it a beginner? What are you trying to do? And so on. I can help, but you'll need to give some more information. But welcome to the stream. Okay, so we're gonna start by opening a good old Explorer, going to core library, and we're gonna put two structs in here, I think, which is, can we just define them in one? Maybe. But let's keep it separate for now. So we're gonna create two new files, which is just a text document. We're calling vector 3 .h, yes, and then copy and paste this again and call it vector 4 .h. That's it. The only thing they will have at the moment is structs, but we might be able to add some more helper functions in the end, right? But for now, just those two. I could also make them for ints, but I think it's fine with floats, or you can make it templated even. That might be a better way of doing it. Yes, okay, I have an idea. So, we got these. Let's go and leave this open for now, but just minimize it. CMake. We're gonna add them in here. So we got vector 3.h and vector4.h. And if we did everything correctly, once we rebuild 0 check, where's rebuild? I don't know why I have to rebuild. Then we will have those files in here as well. Perfect. Okay, so what is the question? Petro, I mispronounced your name, I'm sorry. I've learned the basics of Python, but I don't know what to do next. I'm planning probably programming a website or a game. I don't know how to start though. Okay, so, good question. If you're trying to make a website, you're gonna have to learn HTML. Luckily for you, it's not that hard. It's literally just specifying what you want. Having to style it takes a little bit more. Well, it's basically just giving colors, giving sizes, lining things out and stuff. So it's not that super hard, but it has been known that HTML and CSS can fight a little bit with each other, and it might not always expect you what to do, and it gets more complicated if you want to support more things, more screen sizes, more things, be more dynamic, stuff like that. But a basic website, pretty easy to do if you just learn HTML. It might look like a website from the 90s, but it's a good place to start. Other than that, if you already know Python, making a game is quite easy. There is a library in Python called Pygame, which gives you all the tools you need. And then I would just recommend making like a small arcade style game, or make a clone of an already existing game like Tetris or Snake or Pac-Man. Just a small, simple arcade game. It's a good way of starting out, learning the basics, how everything works, and that's basically it. I think that's most of what I would say is good for a beginner. Okay, so we're gonna make a struct vector3 f, which is the float version. So we're gonna do x, y, and z. We don't need anything else here. And then we're gonna do a type def, or do a using. Let's do a using. Float3 equals vector3f. So if you want to use float3, we can. If we want to use vector3, that's awesome. Fine. I'm almost thinking of not putting them in a namespace. I'm not sure though. Because it will be annoying, because we'll always have to type like float3 when I just want to float3, right? I don't want to do that, so maybe I just remove the namespace. That might cause issues in the future though. But then a simple find and replace should fix everything. I think this is fine for now. That's all we need. Okay, that's vector3, so let's just copy this over. Same thing for a vector4, which will be a float4 and a vector4. And that will be x, y, z, and w, which is standardly called to be the last element. Okay, that's those. So we got those. Now to make our vertex data, which will, I mean, this might not be the best way. I need to have a think about how to do it properly, but for now I'll just implement what we need, which I think is a good way of doing things. So inside of render API, let's open our folder again. So let's go to render API. We're also gonna add a new file in here, but this one can be just under here. Yeah, that's fine. And then let's call it vertex data. No, let's just call it vertex for now. And then do vertex.h. Yes, I want to change the file. I don't know why it still asks me. It should know by now. And here, same thing. We're gonna add vertex.h, which is fine. We're gonna rerun this. And then we have it in here, and we can do a pragma once again. And then we're gonna include some stuff. What are we gonna include? We're gonna include vertex vector3. Damn. Type it right. Vector3, and we're also gonna do vector4. And then the vertex we are gonna put in a namespace because it's not a general concept, so put it in HP render. Namespace, if you don't know, is basically like kind of folders. So that means that you'll need to put the namespace identifier in there before you can actually access it. So if we do a struct vertex, then in here we're gonna have a float 3, which will be the position, and a float 4. That's not what we want. m.color. Okay, that's what we have currently. We might add more of these vertex structs in the future. I don't know yet. I really for now this is perfectly fine. We might just make a post call. We might just call it like a post call vertex in the future, but for now this is perfectly fine. Perfectly fine. Done. Great. Okay. Now let's create a triangle. So how we're gonna do that? Inside this main, right, we do app.initialize, and this is overridden so we can actually initialize stuff in here. Currently, what I have is I create Windows applications and I do load assets. This load assets function should not be in render API, I think. Let me double check first. What this is actually doing, it's creating an empty root signature. I don't know why we need that though. Why do we need that? I forgot. We put the signature. And here, yeah. Why do we use this? Oh, this is for the pipeline. Okay. So we might use this in the future, but for now we're just gonna say, we're just gonna make this, right? So we're just gonna yoink this. Copy. We're gonna copy it for now because we still need that. We're gonna put it in. Okay, so inside here we're gonna say setup triangle. This is bad for the moment, but it's fine. I'll enter. Alright, so we got our triangle. Data. Done. Aspect ratio we don't need to worry about. Let's just do that. And that's all our triangle data is gonna be, right? That's all we need. Okay. What do we need to do with this triangle data? Well, I don't actually know. Oh boy. What I think eventually want to do is basically just say render API dot create mesh, something like that, and that will do everything for us. Maybe. I'm not sure. Okay, so we got our data here. What do we also need is we need a way of telling it how it needs to be drawn to the screen, and we also need to make sure that the render API knows about this, so we need some kind of managing object that groups our vertex data and our material together, I think. Which would be like a renderable object kind of struct kind of thing. Let's go back to our render API. Let's take a look at what we actually need to do outside. So let's go here first. So initialize, what do we need to do? We give the window. I don't actually know why. Do we still need the window? I think we still need the window for like just this one call, no? Yeah, we make a window association with the factory. I think that's all we use it for. So I don't think we actually need to set this. Okay, so there, window. Oh, and do get width and get height. Why do we do that on the render API though? Is this called? It's just for the aspect ratio, but we won't use that anymore. Okay. If we can get rid of that window, that's actually gonna be nice. I mean, the keeping track of the window. That would be nice. Okay, we can get rid of that. So what else do we need to do? Initialize just sets up the viewport in the scissor rectangle, which is also just width and height. Okay. Debug layer, which is fine. Now we make a factory, and the factory we use to make the device. That's also all still needed. That's not specific. Then we get the window to make a swap chain, and we put the swap chain in a swap chain. We got the frame index. Yeah, that's all fine. Descriptor heap. So we make a render target as well. Okay. All good. Yeah. What do we actually do? We just make a render function. We could probably already move all of these things to DirectX 12. Oh no, this is the definition of the class, I remember. Oh, that's gonna be annoying. Okay. Ah, boy. Okay. I should really learn how to do graphics programming properly. Again, then we load the assets. Root signature, I don't really know why we use it. So actually, let's find our empty Chrome tab. Let's do that. Let's do that. And then this describes the layout of a root signature. What is a root signature? So it will create. Where's the out? It will. It's used to create one, right? So we do a serialize, right? Serialize root signature, and then we do a create root signature. So I want to see what that does. Which gives us a blob of data for the root signature. What does the create root signature do? Creates a root signature layout. Pointed to the source data. What is a root signature? Okay, let's do that. What resources are bound to the graphics pipeline? A root signature is configured by the app and links command lists to the resources the shader require. Currently, there is one graphics and one compute root signature per application. So we should have one root signature, okay. And that's all the information I get. A root signature configures that. Okay, well, this is programming, by the way. Reading documentation, that's a lot of what I do on a daily basis. The root signatures are independent of each other. Okay. A root signature is similar to the API function signature. It determines the type of data the shader should expect, but does not define actual memory or data. A root parameter is one entry in the root signature. Actual value of root parameters set and change at runtime are called root arguments. Change the root argument changes the data the shader reads. Okay, interesting. The root signature contains three types of parameters: root constants, constants inline in the root arguments; root descriptors, descriptors inline in the root arguments; and descriptor tables, pointers to range of descriptors in the descriptor heap. Whew. Oh boy. The root constants are inlined to the bits that show up in the shader as a constant buffer. Okay, the inline root descriptors should contain blah blah blah, limited constant buffer values. Can be used in the root descriptor. Root descriptors do not include the side limit, so it can be unlike descriptor heaps, which do include the size. Okay. Which some constraints impose, so let's give it hardware. Regardless of the level of hardware, applications should always try to make the root scene as small as needed for maximum efficiency. Okay, so small size better. Applications have a trait of more descriptive tables in the root signature but less room for room constants or vice versa. Okay, so this is just basically saying this is all the references of data I'm gonna need, which can either be just pure parameters in there, pure constants in there, or a pointer to some data on the descriptor heap. And the descriptor heap is some other object I'm pretty sure we also make, which is somewhere in here. Where's our descriptor heap? I know we make this. We might actually make it before the root signature. Let's load assets. Descriptor handle. See, I think we already make the descriptor heap here. Current bef buffer, and then we get the descriptor heap here. So don't we need to put this in the root signature then? So render target heap. Okay, so we have a render target view heap, and I'm pretty sure we will, when we load the asset, we will also put it in the root signature at some point, no? We should. No? Huh. Oh, also I can close this. Hold on, what? Didn't I read that correctly? Okay, let's see where we use root signature. We use it here to make the graphics pipeline, to create our PSO, which you also need to read up on. Any other references to root signature? Yes. Graphics root signature for the command list. Okay. And then because we do set render targets on there. Okay. Damn. Yo man, that's great. Wish you the best. I really want to be a great C++ programmer someday. Yeah. I love C++ a lot, and I hope Rust doesn't take over the... I mean, I've had a streamer where some Rust enthusiast was in the chat as well, was like complaining to me like, why are you using C++? Go on, why not using Rust? It's memory safe. I don't care. I have a preference for C++. I'm gonna code C++. I don't think it will be obsolete in anytime soon. So yeah, I think it's perfectly fine. Quite flexible, which could trade. Let's go. Okay, so we read that. The concept of root signature, destructive tables, root constant, and root descriptors. Application bound to. Hello, welcome to the stream. We're reading documentation. So, yeah. Reading documentation. I'm looking into how to set up the root signature correctly for the application, because we only have one. Okay, so binary objects share the same root signature. I think I'm just gonna have to look at an example that will make more sense. After root signature is set on the pipeline, all bindings that it defines can each be set or changed, including inheritance into bundles. I don't know what that even means. Root signature. How to use? Is there one? Okay, using. Use a constants, example, root signatures. Oh, that's also gonna be useful. If I find your programming to very impressive, I've seen your past lives. Oh, welcome back then. Welcome back to the programming live streams. If you find this impressive, this is technically basic stuff and I'm already struggling, so I don't know what that's all about. Just give me example. Okay, here we go. Example. So an example which should unlike to be useful, but it could be trivial. Okay, so you can put that in there. If you want to put one constant in there, how does that work? The API binds a slot where the root argument of pair will be bound at the command record time. The number of API bind slots is implicit based on the order of parameters in root signature. First always 0. Okay. So to binding constants, a command list is that. Okay. So just set thing in there. Okay. And what do we set in there? Seed. So whatever seed is will be in there. Okay. To bind the command list. Okay. So that's what we do. Okay. The example shows two rows containing a root a constant buffer view. So let's see. Basically, we're adding a constant root buffer in there, which would just be set graphics root constant view buffer in there. Okay. Binding the strip tables. Oh, there's a. Would you be interested in working on a game perhaps? I'm working with a team right now and would love to work with people of your expertise. The programmers would be keen to meet you. I'm sorry, man. I have a job in game development. I'm already doing this behind hours. I don't need something else to work on. I think one project at a time is more than enough. I basically do this for a living and now I do it in my free time as well. It's more than enough already. But I hope you have fun time making your own game. I think it's really cool to do, especially if you start from scratch. But even if you work with an engine like Godot or Unity, it's the most fun. And if you have a cool team working together, it can be loads of fun to just bounce ideas on top of each other. And if you just see it growing over time, it's really satisfying and really rewarding. Okay, so floats. Okay, so we put a constant in there. I know how to do that now because that's just compute root bit constant. For d words inside. So that's set root compatible. So we bind this to 0. And we're gonna say starting, I don't know, set 1. Alright, so descriptor table. And then we do the handle to in the tape type. Okay. Okay. Just my mind that someone else doesn't care. It's just, yeah, I mean, programming language, there's also gonna be, every time you have just a programming language, there's like a use case for it. I mean, for an example, Python is very good at prototyping things, JavaScript is very good for the web, C++ is very good for low level, and I'm pretty sure Rust is also just good in any case. C++ is good, but then I don't fancy learning a new language at the moment. And thank you, JIT Productions, or GIT Productions. It's very inspiring. Yeah, thank you very much. And it's file system implementation with Livestream. Yeah, that's the basics, like you said. I mean, even the basics, if you go deep in them, you can have some very obscure knowledge, which could be useful in some cases. Okay, so bulk complex root signature. So I kind of know how this works now. We just bind them via the command list, which makes absolute no sense to me. Why you would do it there and not do the constants beforehand. I even made some casino game management, but then when I see real world application, it looks like I don't know anything. Don't worry about it. I started off making my own game when I was didn't even know what to do, and it didn't turn out great. With time you learn things, with time and experience, and you get better at it. I'm by no means perfect at programming either. Okay, so this descriptor tables are basically pointers to some other data, which we'll have to look at how to set up, but I think that's a resource heap. Yeah, syntax is most important, that's correct. Okay, so if I understand this correctly, we set the correct, and then whatever we do afterwards, we just can add stuff in here that we want, which we set and put a sampler vertex buffer in here if we want it. So if we want something in there, we could put it in there. But I don't think we need anything in a root signature at the moment. Right? We just need This should be defined by an application to have the following entries each. Can we set... This is example root signatures, right? But that's all setting it via the root signature. I started learning C today, and YouTube's already trying to get me to quit by showing such Cupid on my feet. Don't worry about it. I'm a noob level game developer at this point as well. I'm struggling here. I'm reading documentations for Christ's sake. Okay, so can we bind any other way than just by doing it? With the use of only the input assembler and minimal versus pixel, I can do analysis and descriptors. Yeah, see, we can already do this, which means that we can have an empty root signature. I understand that now. But is there a way of adding things to the root signature by not doing it in there? Let's see if we can do this. Oh, that's not helpful at all. Okay. Do we have... What is this? Specifying root signatures in HLSL? Ugh. Okay, they're not worrying about that now either. Okay. I'm guessing this was the same thing, right? No. Oh, that will be an issue when we actually make shaders. Okay. Creating a root signature limits. That might be interesting to read. Okay, and then let's see if we can actually specify it. Okay, so setting constant on root signature. Let's see if there's another way to doing it. Okay, let's look at another person how he does it. Okay, my root signature description, count of parameters, count of static samplers. Oh, I already have that as well. Wait, hold on. That's good information. I just glossed over at the beginning. We make a root signature. Where is it? I lost my root signature. Load assets. Here it is. Root signature. We have 0 parameters, 0 static samplers. Good to know. So that's why it's empty. Okay, we make an empty one for now. That's perfectly fine. We don't need to do this. How long have you been doing this, and what got you into programming? Well, first off, I started programming when I was about 12. I started learning C++, gave up after like a month or two. And then there was a big gap in time, 2 or 3, 4 years maybe. And then we got like a small little programming course in our ICT class. And I was hooked again. Started learning, I was a basic version of C++ again, but way simpler than I had learned on my own, way more structured as well. So it was really easy to follow along and follow with the concepts, learn the syntax. I was basically optimized for children to learn programming, which is great. After that, yeah, just continued doing different languages, started making my own websites because that was the easiest. HTML, a very easy language to learn. I wouldn't even call it a programming language. And it's very visual, so you get a result immediately, especially if you learn CSS as well, which you can use to style it. You can add some basic scripting to it with JavaScript, and then it just kept growing and growing and growing, and now I'm here. I studied engineering, which was a lot more programming as well, and then after that I did game development. Yeah, no, didn't know why that took so long to find in my head, but yeah, I did game development, and then I got a job as a game developer, and I'm programming for a living now, and I do this on the side. So, and if you're talking about how long I've been doing this project, I think I started 2 months ago now, and we're still at the stage. Actually, that didn't show anybody yet how far we got. So let's actually make it compile, because I have not shown today what we actually have. So I'm pretty sure in the application class, oh no, that might work. Okay, so I think we just can compile it. And then you can see how far our game engine is going. And then you might all be a little bit more forgiving with me and see that I'm actually a noob. Because the only thing I have at the moment is a triangle. It's a color triangle. It's a color triangle. But yeah, we're trying to make that triangle a bit more generic so that we can spawn another one if you want to. And then hopefully by the end of maybe next stream we can have a cube. That would be interesting. But yeah, okay, let's actually continue this. So I know what the root signature is now. I think it's fine if we leave it empty. Can we bind it in any other way? We can call an init, which already gives us our root parameters. Do we call init as well? Oh my god. Where is my file? I lost the file. This one. We do create root signature. Do we even call init on it? No. Oh no, that's a description. We also init the description, I think. We serialize it, yeah. Oh, we can call init to do this, but I don't like that. No, that's fine. Oh, and we can pass it the pointer to the parameters already. Okay, that makes more sense. Now we get it, so I can already specify them here, but I can specify it more later on. Okay. Yeah. Okay. We need to make it empty anyway for now, so I'm not gonna read too much into it. But if we make other shaders, we can think about it later again. So I'm gonna do in here, can assign more data in it, data to it for shaders later on. Because later on we will have like camera information, light information, and we'll need to pass all of that information to the shaders. And I think the root signatures would be the way to do that. Or we can do it with the descriptor heaps, which I was gonna read on next, because we do make a descriptor heap for render targets, and I'm not pretty sure. I mean, I kind of know what it is, but I want to read a bit more about it, because that would help. Okay, so we got that, and then we can get a descriptor heap, so we're gonna read about that. Okay, so what does this do? It's a collection of continuous allocation of descriptors, one allocation for every descriptor. Descriptor heaps contain many objects that are not part of the pipeline state object. We also need to learn what the pipeline state object is. That's another one we need to do. Okay, so let's read on of descriptor heaps. So let's take the overview, and now we have shader physically creating descriptor heaps. To create setting and populating descriptor heaps. Okay. Whew. I don't think we would read so much documentation today. I was hoping to do actually all of it. Okay, purpose is to encompass the bulk of memory allocation. Okay, good. All heaps are virtual to the CPU, and we can probably send them to the GPU as well. Okay, so at most one of these things, combined heap and one sampler heap, can be bound at one time. These heaps are shared between both graphics and computer partners, described in the PSO. We still need to know what the PSO is. That's the next thing we need to learn. It is acceptable for an application to swap heaps with the same command list in a different ones using the set descriptor heaps and reset on some arbitraries because we expense operation current. Okay. So if possible, we do not want to swap descriptor heaps. All this code for triangle? Yeah, it is wild. Although it is it's not a very optimized code. I could write, we started off writing this whole thing in one single file, and it was like, I think 400 lines of code, which is not that bad to render a triangle to the screen. But now we're splitting it up, making it more generic, making it have an actual architecture that's fit for a game engine. Okay, so let's see, how many descriptor heaps do we actually bind here? Do we actually bind anything? Where's the render command for this one? We just set render targets. I've seen anyone looking at docs like this. Yeah, well, I don't think we do set descriptor heaps at any point here. No, we just set a bunch of things for the resource. I need to know what all of these stages are, and then it will be all clear, I think, what we need to do, what we need to have, what will be part of the model, what will be part of what's actually anything else. I don't think we need a descriptor heap either. We just need to know what a render target is, but we know what the render target is. It's basically what we're drawing to. So the render targets are stored in the descriptor heap, and we bind them with this command, and we always need to do it. At some point I want to make sure that we actually do all of this, and then this is actually drawing the actual model. This is our triangle that we're drawing here. Why am I building my own game engine instead of using one like Unity? Well, mostly it's pure interest. I think it's very interesting to learn how everything works behind the scenes, and the best way to learn is by actually creating one. So that's one reason to go about it. Secondly, how cool is it if you can say that you've made a full game completely from scratch? And I mean completely from scratch. I mean, that just sounds insane to me. So I want to be able to say that at some point. Okay, This is a triangle, so this will become like a render function, right? But we need to know what to render, and we need to know what the command list is. Oh, this is gonna be so complicated to do properly. I already want to start implementing ECS just for this, which I won't. Okay, so we need to work out what this does, what stage that is in, because I think that will be useful. Was curious, triangle came out of file. So how the triangle is basically just me specifying coordinates on the screen like this. So this is just from 0.5, from 0 to 0.25, 0, right? This is the x coordinate, the y coordinate, and then we got 3 points, which each have a color, and that will result into eventually a triangle on the screen. That's how I draw it. In your experience in programming till now, what's the best way to figure out a solution to a problem that you get stuck at during work? Most of the time, it's just throwing shit to the wall and see what sticks. That's one way of doing it. So if you have a problem, first of all, it depends on what problem. If it's an architectural problem, you go to the drawing board, you take pen and paper, and you try and write out what you can do. Then you try it out in some small examples, see if it works. If not, move on to the next solution. If you really get stuck, there's always people you can talk to at work, so that's pretty nice. And then we have the whole internet as well. Most of the time, if you're programming, it's already a solved problem. Somebody else will have fixed it for you. Secondly, if it's a bug in your code, it's just a lot of debugging. So basically what you're going to try to do with debugging is get a smaller and smaller scope of where the problem is located in. So first of all, you're gonna maybe see like, okay, what's the state of my program here? What's the state of the program there? Like a lot later in the program, see is anything wrong here or is it what I expected? And then you're just gonna reduce that scope every single time until you get to the problem. But that's in theory. In practice it's a lot more complicated, but that's a good way of getting started with things. Man, so many questions today. I'm on a program. Okay, so what's curious is that a C++ that does a game. Are you writing in C#? No, this is C++, although C# might be used at some point in this project, but not nearly. Not in the future, maybe. Game stuff and the ones with low-level stuff like kernel and compiler, are they different? No, I mean, I'm not sure what you mean by that. The reason I'm using C++ for a game engine is because we need to access a lot of low-level stuff, like we need to manually specify things in memory, and we need to be as close to our operating system as possible, which is the kernel. That's why we use C++. And what the compiler does is take all of this written code and just jam it all into some kind of language that our computer can actually understand and execute. Because our computer can't read like, oh, this is a vertex buffer. It doesn't know that. It will just get instructions, what will be fed to the CPU, and then it will work. Cookie clicker clone. Yeah, that's perfectly fine. That's a really good way of getting started with programming, and Cookie Clicker is a fun game to make. In C#, interesting. So you're probably using like WPF for graphics then, or like some kind of Windows library for graphics. Although I'm not sure what you're coding on. Could be on Mac as well, and then it's completely different. Either way, okay. So we got all of that. We know we don't need to set any of that things up. But I was looking at the set viewports method because I want to know what the stages are. There we go. Can we actually find out what it is? Nope, we're just gonna look for... Let's just do DirectX 12 stages. Pipeline and shader with DirectX 12, okay. Oh, that's a diagram if I've ever seen one. Yes, I am Belgian. I live in Belgium. Computing, no. Graphics pipeline, this is it. I can't open a new tab, there we go. So, this is gonna be everything we have. So, all of these stages we're gonna have to set up. It's probably the accent and my language on my PC, that's probably how you know. It's a good guess, you have two guesses. It's this or the Netherlands. Okay, so, input assembler. Then we have a vertex, hole shader, tessellator, domain, geometry, rasterizer, pixel shader, and output merger. What we need is the input assembler, which will take all of our data. And then together with all of this information, which we don't use yet, that will work into the vertex shader, which will put it into pixels, and then with pixel shaders. Okay. Basically like that. No. Hey, hold on now, hold on. Keep it. No, it's probably easy to guess. I'm pretty sure the accent is pretty recognizable as a Dutch accent. So then you have two guesses, which is either Belgian or just from Netherlands. So that's a good guess. 50-50 chance, you got it. So congratulations. Okay. So here's how I see it. Input assembler, we do need to set up. All of this will be the shader. So this is the model. This is the shader. And then this is whatever we have left. Okay. Whew, that's a lot of working documentation. Okay, so let's go check out our command thingy again. So we can see it here. So we have the rasterization stage, we'll set up here. We have output merger, which sets up the render targets, which is what we see. Input assembler, this is of course draw instance. I don't actually know. Oh, this is all input assembler stuff. Okay. And then do I have to set up the actual... Where do I bind the shader? Need to bind the shader somewhere. Where's the shader? Shader. Okay. Input element. Oh, we bind it in the PSO? Oh, I still need to look up the PSO. I thought I was done. I'm still about to start my engineering in about a month or two. Yes. Trying to learn C before college. It's a good way of going about it. If you're learning C though, you might want to look into... I think Code Academy has a course on C. I think it's free. It's a good place to start. Or you can pick up a book as well. I think most libraries have a standard book on C. You can read, and most of them go up quite deep into the basics. What's a buffer? A buffer is a place to store data. It's basically... we have our memory, we allocate a buffer, which just say we're gonna have this part in memory that has something. Name, I'm not gonna say. If you're smart, you can figure it out when I show something wrong on my PC, but I mean, If you really want to know, I think it's somewhere in the description, maybe. I think my website is in the description, so it should be in there. Not 100% sure though. I don't actually know. Okay, either way, I still need to look up PSO. It's the last thing I need to go and look up before we can work on anything. So we got this. That's the description. I should have clicked on the other thing as well. Okay, so no code structures. No. Great graphics pipeline state. Man, a lot of people studying computer sciences or engineering or anything related to that. Okay, so pipeline state object. Okay, what is this? I kind of know what it is probably, but we still need to figure it out. There should be like a... Wait, it doesn't say what a pipeline state is? Oh my god. It presents a state of all the current set shaders as well as certain fixed function state objects. Okay, great. Okay, so we have a graphics pipeline state object. A pipeline state object corresponds to the sequence portion of the state. I'm pretty sure this will do everything shader related. So we set up a shader, which will be a material, and then we give it some vertex data, and then it will print it to the screen. I think that's about it. Okay, what's a pageable? Okay, that's just core interfaces. If I go to core interfaces and I look at PSO, does it say in here? But I think, hold on. Do I not have my own Discord and my own description? That's a mistake. Hold on, give me 1 second. OmniGamers is an old one. Well, not specifically an old one, but it's also a pretty interesting community, but it's not my own. Okay, let's see. My own channel. Let's go to live here. Can we just edit? No, apparently not. No, let's not try it. Stream settings. Title programming, how to style. Anyway, I'll fix it later. If you want, if you want to join my Discord, let's just put it in the description here. Let's do a invite to server. Copy. There we go. And then if you do want to join the actual Discord, this is the one. I was curious what you would watch this documentary coming out the next 2 days. No. I don't know about any documentary coming out. I do know there's a gaming related event coming up soon. Okay, let's just wing it. Pipeline state object. Okay, so this is the thing that sets things up. Let's just see if we can see. Did I close it? No, I didn't. If there's a... Okay, this one. Pipeline state object. Shader bytecode, pipeline stage description, and other setting. Okay, so this is basically how our material is gonna function. Blend state, rasterization state, yes, tap stencil state. So we're gonna have to switch this out. Pipeline state stream, root signature. Okay. That 2 bytecode generation, I have all of that. I'm not actually sure if we have to X12 switch shader. How performance to switch? I'm wondering how performance. I'm getting reports. Oh, a lot of people working with Godot, I see. Learning GD script. Unnamed it's impossible to try to microcode a sample with it and get catch lots. Understand what to do with patch shader. Okay, for now, we're gonna just work with one shader. Okay, so how are we gonna do this? We have one shader which will get our information. So we're set up our pipeline state once, get our information, and then we should not do this again, but we can. Yeah, we have one pipeline state, and I'm not sure actually. The only thing we do here is just reset it. And then do we do anything else with the PSO? No. So we just set up the pipeline and that's it? Interesting. Okay. Very interesting. Either way, that's how it's gonna work apparently. So how do we go about it? I guess we make our shader, which will be this, right? My Gmail is showing that. Don't worry about it. That's fine. In a programming language, you should keep it private. No, that's fine. Okay, Gmail is just my junk mail anyway. So let's go and go ahead and give it graphic pipeline state. Game engines when you complete it. I don't think I will open source my game engine if that's the question. Although we're far from complete, as you can see. But I mean, we'll figure it out eventually. For now, I think by the work I put into it, it makes more sense to keep it private. But the opinion on that can change later on. Not even sure if I will sell it, to be honest. This might just be something for me specifically, but in the end, who knows? I mean, by the time I finish this, there might be already a new game engine that will make this obsolete, and you should use that one instead of this, but oh well. For now, I'm using this one. So we need to set this up, which is so annoying. Because I need to set it up at the beginning, which is wrong, because I want... Okay, I'm gonna make a note for myself, and that's how to... I'm gonna research this off camera, because it might take too long. But it's gonna be swapping shaders. So I'm gonna make... we can do this afterwards. Correct shaders, I'm gonna call it. And do it performantly swap shaders. I do have a GitHub. Man, I really should up my description of my videos, right? Can I see it here? I don't think so. No, apparently not. Okay. Either way. Yeah, well, let me just try and find it. Hold on. Let me just see how bad my description is actually looking. Let's do this actually, I can do that, yeah. Edit title and description, oh there we go. Oh, I can put it in here. Oh wow, there's nothing in here, damn. Okay, so let's do Instagram, Discord, let me actually update it live. Okay, so Discord, I think I already have, nope, apparently not. That one, okay, but that link will not work. I'll be fine for now. And then let's put GitHub in here as well. Hey, I'm doing this all for you. GitHub. I do think most of my GitHub is private. And can I do that? And then do this? Okay. Save. I think it should be updated. GitHub should be in the description now. Okay. Damn. Did you know in C# you can use this to upscale text? I'm using C++, but thanks for the tip. Thanks for subscribing as well. And did I miss anything else while I was updating my things? I don't think so. Okay. So, performance swap shaders, and then probably... No, that's all we need. I might need to look into vertex data. Custom vertex data, let's put it that way. But that's fine for now. Okay, so let's actually do something today, because I don't think we've actually programmed that much. We got our vertex, that's good. Now we need to make a shader as well, and then we can load the shader and load the model. And at the moment, currently, we will only have one shader. So in initialize, we do this load assets, right? That will not be the case, but we'll make that, and then we're also gonna make a shader. So let's make a render shader. And shader. And we need to actually create all of this. Okay, so how we're gonna do creating that? First of all, we need, again, just a normal file in here. So do new text document. Let's call it shader.h. Yes, I'm sure. Good. Okay, so we got our shader in here. We can close this. And then we might need to make a CPP file for that in the future. For now, let's just do a shader.h and rebuild. Where is it? Rebuild. Okay. The thing is, for a shader, I think we'll need a basic implementation and then a DirectX 12 one, which I don't think I've actually set up like the way I wanted it to, right? Oh no, we did create application window here. Okay, that's great, because you need to do kind of the same thing. Okay. So we're gonna do a shader pointer instead, actually. And we're gonna do equals create HP render. I'm breaking everything at the moment. Create shader. Okay, so this basics version, not sure what's gonna be in here. We're just gonna set it up. So the namespace, my namespace HP render, and we're gonna throw in a struct shader in here, do that, and that's it. We're not putting anything in there yet. Okay, can we inherit from two classes at once? Of course we can. Yes, we can. It's used a lot, especially with interfaces, which means that you just have a class with just like a bunch of functions, like generate or something. And then you can have a bunch of basic functions in different classes, inherit from both of those classes, and you'll have all of the functions. Alright, basic shader. Then inside our actual DirectX 12 one, we're gonna add two new classes, two new files. We're gonna call it DirectX 12 shader.h. Actually, speaking of inheritance, we'll use some in a second. Let me just make all of these files. Eventually I want to make like a plugin for this, so I don't have to manually do it every single time, because on top of that I also need to up this and put let's just do that, no h, and then do this shader, and then recompile, rebuild this. Okay, that's done. Got all of that finished up. We got our shader in here. Okay, so first of all, pragma once again. And then we're gonna include shader.h. Shader.h. Okay, there we go. And then we're gonna do a namespace, which is DirectX 12. How did I call it? HP DirectX 12? Or is it just DirectX 12? HP render and then just, okay, so the same thing. Between inheritance and friend, you should almost never use a friend. Always use inheritance when you can, and even better, always use composition if you can use composition. Which means that you're just gonna make a member out of something. Okay, that's correct. And then we're gonna do public here. It's public inheritance. Let's do that in there as well. Okay, now we got our setup here. What we're gonna do now is inside our application, I think, where did we have our function for that? Hold on a second. Let's go back to our application class. We have this, right? Which is in create application helpers in engine core. In engine core. Wait, where is this? Oh, engine core is... Oh yeah, no, this is correct. Uh-huh. Okay, so that's Win32. So inside engine core, didn't I not add a DirectX 12 C++? Yes. Oh, that's not HP platform, that's HP... how did I call it? Is it render? I think that's it. Oh boy. Okay, let's check this. No, okay. This one, platform render DirectX 12. Okay, so let's recompile. No, not this, not this. Ah, clicking all the wrong things. Let's recompile this. Okay. Friend classes are barely used. Most of the time, if you have a friend class, you're doing something weird. I wouldn't say wrong, but at least something weird. Okay, so inside here, we're just gonna include create application helpers. And then we're gonna do another one in here, which is HP render and shader. And we're gonna call create shader. Class shader. And what this will allow us to do is create a shader. But it will allow us to create a DirectX 12 shader because we are being smart about it. Create shader. What? Oh, I'm gonna have to type it out. I don't want to type it out. Yo, just give me this. Copy that in here. There we go. And then do HP render. Oh my god. Create shader and then boop and then boop, and then we're gonna return an ls, no, not ls, HP make unique, create unique pointer. Did I call it create unique pointer? Oh, okay. HP render shader, but not a normal shader. We're gonna use a DirectX 12 shader, and then we're gonna import that with this, and we're done. And what are you complaining about? Namespace has no member. What? Yes, it does. Oh, it's just an HP. Oops. Yoink. Create shader. And then an application. Actually, no, let's put it in render. I do think it makes more sense in render, so let's make another namespace. HP render. Put that in there. Boop. There we go. And then render. Whew. And then we don't create that, but we create a unique pointer. HP unique pointer of shader. HP render shader. Got to go now, so it's late over here. I bookmarked it. Oh, thank you very much if you're gonna watch the video. Thanks for stopping by, and I hope to see you in another stream. It was fun having you around. Okay, we got all of that set up now. We got a shader. It does nothing at the moment, but we got our structure set up, and we're gonna have to create that structure a lot more in the future as well. But now let's actually think about what we need inside the shader. We need to load it. We need to bind it, I guess. Okay, so let's create a shader default. Let's also create a virtual destructor, because I know somebody else will complain about it. Okay. Shader, and it's gonna be virtual. And then we're gonna do delete, copy and delete move for shader, because I don't think we'll need to do any of that. And we're gonna do that all in public, of course. That's all fine. And then I think we'll need a load function probably. Then we're gonna need a bind function. And I think that's it. And these are all gonna be, of course, null without implementation. Virtual, oops. That's basic knowledge, come on, you can do it here. Virtual bind equals null. There we go. And that will force us to implement them in a DirectX 12 shader. So we're gonna publicly create a shader, which will be shader that, which is also default for the moment. We might give it some other information in the future. That, which is also default. Did I? Oh, and this should be final. Is this the normal one? I should make that one default as well. Hello, professional coder. I can also go the string text and print text. You're here to learn C# while I'm programming in C++, which is kind of the same as C#, but there's memory management involved. Delete, copy and delete move from DirectX 12 shader. There we go. And then we're gonna have our implementation of our load function and our implementation of our bind function. Okay. And then we're gonna have some private stuff in here as well, because that's the whole point. What do we need in here? I don't know yet. Although I do know some things, right? We need, it's a shader. So what do we need? We need a, come on. Where is my render? I already paused it, didn't I? Where is it? Oh, I'm just gonna have to find it in here then, don't I? The render API. Okay. So we're basically gonna make these. That's what the load is gonna do. So what this will do is compile the file. So we need the path. So we need the path. What do you recommend for me to start coding in Unity? C++? No, Unity is C# specific, so you will need to learn C#. That being said, if you know C++, you can easily switch over to C#. The other way around, not that easy, because C# does not, well, does have managed memory, so you don't need to manage the memory yourself. While in C++ you do need to manage memory yourself. It's a lot more low level, so it's a lot less of holding hands. But I do think C# is a good language to start out with and learn that one first. And of course, all the basic concepts you will just be able to get from, if you learn C#, you'll still get all the basic programming concepts, so you're not losing out anything. And with Unity, you can quickly make a game as well, so it will be more rewarding to actually do and learn C#, I think. Okay, so render API, we're gonna do shader. Where's my shader gone? Shader in here. No, not that one. This one. We will have, oh no, I need to decide now. Do I just do const jar pointers? Maybe. How fast can I learn C#? If you know a little bit of programming languages, you might be able to do it quickly. If you're not sure about how any programming language works, I would suggest... it's a hard one. I think you can actually do Unity. I think a lot of people start out without any programming knowledge, learning Unity and learning how to make a game in it. There's not enough resources for it, so you can actually do it quite quickly. What do I do? Const jars. Oh god, this is a good one. What do I do? Do I just make... Okay, let's just string it for now. M file, buff. I'll do that, that's in there, and then this will do an std string by pointer and do file path. Or we can just do no, let's just do const. I don't want to mess around with moving it here. Okay, so your question is how do I... Oh, you need to go already. I was just gonna answer your question. Oh, it's fine, it's fine. Okay, let's just override this. There we go. That's unfortunate. I was gonna just suggest you also learn... you look up brackeys on the internet, on YouTube. It has a lot of basic tutorials, even if you can't learn... if you don't know anything yet. And that will learn you how to do make a basic game in Unity, including the programming. But yeah, thanks for stopping by. I hope you still heard that last part. Okay, so we're gonna make the... What the hell? Why is it suggesting everything except the thing I need? It's 12. Shader. Oh my god, it's not doing anything. HP render. Next 12 shader. Next 12 shader. This one is the one I need. Okay. So we're gonna just copy over the file path. That's that. Done. Push. Okay. So in our application, this will complain now. Well, it will not complain. That's good. Okay, and then we're gonna yoink that from our render API. Where's my shader path? This one. I'm just gonna copy that. And paste it inside our application. In here, we are gonna copy that path. Apparently, can't do that. Can I do that? Oh, it doesn't have any path. Okay, so create shader will have a const standard string reference file path. And we're gonna copy that through to this. Like that, and then we're gonna do this as well and put it in here, and I think we need to also include that right there. Okay, that works. And technically I actually want to do that. Okay, push done. So now in application it should work. We put a shader in there, and now we need to write the load function. How does the load function work? I don't remember. We need this. And what do? We put compile flags in there, apparently. So we need to do this. This is compiling the shader. And then also that's, but yeah, okay, no, that's also what we need from the shader. Copy that. And then inside the shader, we need this, and then we're gonna make our load function. And we'll do this. Oh boy. Alright, so we don't need that. We need to include unique pointer. No, we don't need DirectX 12 common. Ah! Oh boy. We need this one and this one. Basically this. Okay, so copy that and paste it in here. That will fix all of those things. Throw a failed. I'm not sure if I need. Vertex and pixel shader, we're gonna actually yoink here. And we're gonna store them as members. So vertex shader and pixel shader. We're gonna actually include that. So we're gonna do include DirectX 12 / liquid. That will work. And then we're gonna do struct, no class probably. Whatever this is. Because I don't need the size. Or no, I probably do need it, right? Because I need, I need this thinking. Oh my god. Never mind. We need the size. Okay, so let's see what's actually in here. Like that. Not that one, this one. I don't think that will work, so we'll just do that. And then also you need that to be at the bottom. Okay, apparently we don't need that one. I don't like this disable thing at all. There's no way to do it differently. Okay, so we got all of these things. Inside the shader, we set compile flags, which is fine. Throw a failed, we'll fix in a minute. Vertex shaders M. Vertex shader, pixel shaders M, pixel shader, there we go. There we go. Throw a failed. I still need to make. I think I've just put it in this file, right? Where is this? Oh, we can just make it assert. Oh, that's actually a better way of doing it. Let's make it a runtime assert. Okay, so shader.h, we're gonna make error code. So let's do, wait, hold on, how did I do it? My mouse, where'd my mouse go? Uh-oh, something froze. Oof, oof. We good? Oh boy. I don't know if we're okay. Hold on. What the hell happened there? Let's just do a quick fix here. Uh-oh. Oh, I think it's just you messing up, isn't it? Whew, okay. It's not as bad as I thought. Whew, okay, we're fine. My computer froze up there for a second. Damn. That's the first time. Dropped 25 frames, thank god. Oh boy. Okay, well, we're fine. We're fine. Okay, so we need to do failed HR. So we can do render API. we're gonna do hrvs results, no, h results, hr vertex shader equals compile this, yoink, paste it in here. Oh, my PC's getting really warm. Oh, that's maybe why. Okay, throw a failed, we don't need, but then we're gonna do a runtime assert, which is this, and then we're gonna say succeeded hrvs. Not sure if that will work actually. Okay, maybe it will work. Vertex shader failed to compile. A path percent s. Okay. No, path and then this. And then we're gonna do file path. And also, I don't need this, I just do u dot data. Dot c string? Huh? Oh, it needs to be a white string. Oh my god. Oh well, let's then just do a quick white string. And that should work. That should be that. This should also just do that. And w string. And then the create should also be a white string. And then this should go to definition, which should also be a white string. An application will probably need to be in L, yeah. How's my stream health now? Just tell me, just don't say poor. Oh well, it's fine, it's fine, nothing is burning up. Okay, shader. Okay, so we're compiling it. We build that. If it doesn't succeed, then we will copy it, and then we do the same thing, but with the same compile flags. Also, yeah, that should be there. But we do this one, pixel shader. We'll see pixel shader. Pixel shader failed to compile path there, and then we're gonna do pixel shader. Is that, there we go, and then we're gonna put it in pixel shader, and then we don't need this one either. And then this, I don't think we need. I think we can put that on the vertex. Maybe. Get layout on the vertex, that might make sense actually. Or no, we can put it in here. Either way, it's fine. For now, I think, since we only have one shader, this is bad, but we're gonna say, we're just gonna yoink this for now. There we go, okay. That's that. That's the load, and then the bind we still need to do. So we do a void bind. There we go. And whatever the bind this needs to do. Are we back to good health? Come on, it's been 5 minutes. Either way, okay, so. And then we need to bind this shader, which I'm not sure how to do yet. But we created the shader here, and then we're gonna say render shader.bind or render.api.bind shader. Oh, that's also a good one. I think it's more clever to do render API dot bind shader for now. And then we're gonna just bind at the shader pointer, which will be shader. This object needs to stay alive though. We need to manage lifetimes at the minute, and I don't think we're doing that correctly. Although we can do it very simple, I think. But yeah, this will be better, I think, than doing it on the shader itself. Maybe. We'll see. Whoa. It's getting warm. Okay. So let's get rid of this for the moment. Okay. So we're not gonna do that. Doing that. Why is it delete, copy, and delete move? Oh, I don't have the defines yet. Okay, I'll enter. There we go. It's better, isn't it? You're still saying poor health? Come on, man. What am I calling this project? Oh, welcome back. This is called Homebrew Engine because I'm making it at home. Get it? It's a pun. Programmers are not known for making good names. Oh god. I mean, we are definitely not known for making good names. There's like, if you know programming a little bit, you know what a bit is. A bit is and a byte is. A bit is just one single bit. You have byte, which is 8-bit, and you have a nibble, which is half a byte. So it's a small byte, which is why they call it a nibble. Yeah, it does have a name. It's called Homebrew. That's the name of the engine. What the game itself that I'm gonna make with this doesn't have a name yet. I don't even have a concept for a game yet. I mean, I have some ideas brewing in my head, but nothing concrete at the moment. I hope that answers it now. Okay, so we removed the bind function, but we're gonna put it on the render API. So we're gonna say load assets. No, we're gonna say void bind shader. And then we're gonna say currently only support one shader sad face. Because that's bad. And then this will not take ownership of it. So we're gonna do HP render shader pointer pointer. Why is it pointer shader? And actually we're gonna take it by const pointer. And then we're gonna do a class shader. There we go. Okay. These I don't need anymore actually. But, well, we need them, yeah. And then we're also gonna say the bind mesh. What did I call it? Yeah, bind mesh. Which will take a const HP render. No, it's just const HP vertex. Pointer vertices. No. Oh, this is gonna be tricky. Okay, this one I'll come back to. Okay, stream is healthy. Thank God. Why did you take 10 minutes to decide that? That was fixed in a second. Okay, bind shader. We are gonna implement now. We're gonna implement it in render API. So this should be in here. Then we're gonna do. Let's put it at the bottom. Bind shader. Oh my God! Just find it. Oh my God. Bind shader. There we go. Finally. Okay, and this will implement it. So this will create our PSO. Where is our PSO? This one. Let's will do this. So yoink that. Oh, no, what? Okay. Okay, so we're just doing this. Copy all the way to the bottom and paste it here. Okay. So shader. We need to get the layouts. So what we're gonna do is, first of all, we're gonna do DirectX 12 shader equals. I did the same for the window, I think. Let's see. Right, I did window and then I casted it up to a DirectX 12 window at some point. Or is that just in my DirectX 12 window? No, that's a render window. So where do I cast render window up to DirectX 12 window? Okay, I'll do this. So we're just gonna do that again here at the bottom, but with a shader. And we're gonna cast this one to a shader, which will work perfectly fine to a const. Hold on, const pointer. And same here, const. Tame Impala, Jesus. Yeah, well, my hair is not. I mean, it's hair. Boop, boop, boop. There we go. All the way back to the bottom. Okay, so we got this DirectX 12 shader. What we're gonna do is we're gonna do input element description is gonna be shader.getLayouts. Boom. DirectX 12 shader.getLayouts. So we're gonna get rid of this. Actually, we can do just yoink this, put it in here, get rid of this, and then on DirectX 12 shader, we're gonna make a new function. Stupid question? Ask away. There's no stupid questions, only stupid answers. DirectX 12 shader, no, input. Layout, I think it's called. Right? What was it? I forgot. DirectX 12 input layout description. DirectX 12 input layout description. And it can't resolve that symbol. Great. Hold on. Oh, it's in this one. Let's see if it's that. No, it should find that. Would you rather? Oh, weird question. So, I think Jesus is cooler. It did a lot more miracles. So I'll pick Jesus. I mean, who doesn't want to walk on top of water or just multiply bread? I mean, food for life. You can just run on water, which is weird and cool. It was a weird question. Not stupid, weird. There's a big difference there. Okay, so what is that input? Where's this defined? Is that in this one? Maybe? No, I have that one. Huh? Can I not just have that? Access that? Alright, so let's copy this. Let's open our trusty... Wait. Oh no, I closed it. Oops. This, that. Pop. Okay. Boom. Okay, so what I need is the input layout description. Oh, it's D3. Oh, I just spelled it wrong, didn't I? Yes, I did. Get layout. Const. There we go. And then we're gonna make a void get layout. There we go. And then we're gonna see if we can... That, yeah. So that's an... Copy that. Layout. Oops. Input element description, if I remember. Element description. There we go. Elements. Equals that. Right? Right? That seems okay. Huh, okay. I thought I knew how to do it. Let's just yoink back the top one, which was this. No, wait, yes, this. Oh, yeah, of course, it's an array. It's an array. So let's do make it an array, you fool. There we go. And then that will work. We'll do that. That's an array. And then we're gonna return. Wait, what? Return that elements. Two. Because I know it's two. And that's it. Actually, let's also put that there. Because I want to know what's you. Is that an address? Oh no, wait, what? That should be fine, no? Or is it an issue that's static? Oh, it might be an issue that's static. It might be a pointer to a... Does it need to be managed? I'm not sure. Let's check the code before again. So do that, it is defined, and then we do just pass it along here. And we already created here. And create a command list after it as well. So I'm not sure if we... Okay. I'm thinking here. Hold on a second. So I am pretty sure I will need to specify these layout elements inside it, since it's a pointer. So the way it's set up now is it's basically... Oh, I can make a const expr, I guess. We can probably do expr. Like that, and then it will work, but I don't want to do that. Well, actually that will work. Now it's constant, so it's probably okay. No, let's do it the correct way. So let's put in our shader a member, which is this. Which is shader layouts. m.element. Like that. That will be a pointer. No, it's just hard coded on a list of 2 for now. That's also bad. See, the issue is it's gonna be a temporary variable. So I'm not sure if I need to actually keep it alive. Let's find out. An array of the structure that describes the number of input data, the structure is member of the data. Yeah, so I'm pretty sure I'll need to keep it alive. I'm also looking at the wrong thing. Yeah. So I need to keep this alive, which we will also make on load and then return it. So how we're gonna do that is we're gonna do an array like that. And we should probably make a dynamic array out of it, but oh well. And then we're gonna say elements equals this. Which will be a new array of 2. Or can I do that? No, shit. Probably like that. If I think that's fine, and then we can just remove this. And it should be elements, which will be a pointer, and then we'll say 2. Not sure if that will compile, we'll see. Actually, we can see it very quickly, I think, because we do get layout, and then inside our render API, we do get layout here, right? Wait, at the bottom now. And then we just need to get our shader bytecodes. So we're just gonna yoink this for a second as well, and inside our shader we're gonna do get vertex shader, and then get pixel shader, get vertex shader. Okay, and then we're gonna paste that in here. And it's gonna be shader bytecode, so D3, D12, shader bytecode, like that. And you, boom, done. Vertex shader. Huh? Why does that not work now? Oh, did I store it in a unique pointer? Yes. And how did I store it before? How did I store it before? Here we go. No, it was just pointers and then get buffer pointer. Oh, did I not include the file yet? Turn. That's all that. And then why is the blob not working? Ooh, ugh, no, you should be there. Actually, you should be on top. Like so. Oh, I need to also include ix12 unique pointer. Yes? Maybe? No. No, it's already included. Of course it's already included. Huh. So we do this, which does a pointer. Returns the pointer. Which will just be a blob. and then get buffer pointer and get buffer size. That should work. Unless the blob is not defined yet, which is possible. If I specified it, I didn't. We'll see. I include everything in here, right? These two files, I did. And then in the render API.h. Oh, this one. Probably that one, isn't it? Or shader. Still not. Huh. I'm not sure what I'm missing here. Got those. I got those. Still nothing. Interesting. Why though? Is this undefined? Oh. No, it does no. Get buffer point. Yeah, it knows it. Huh? Alright, let's just leave it because I think this should work. Alright, so let's do the same thing again, but for the pixel shader. If this one works, then it's something weird. No, okay, this one doesn't work either. Okay, those two are set up. So we can get layouts, get those. Okay, so then at the bottom here we can do shader, DirectX 12 shader, get vertex shader, and DirectX 12 shader, get pixel shader. And that should be that all set up. So then we can do bind shader. We'll create our PSO, we'll set our PSO. And then actually we can say descriptor heap load assets. I think we do that. We can we can remove all of this. Like so. And then I hope, wait, do we need the root signature for the pixel shader? Oh, we do, okay. So inside initialize, I'm already gonna create the root signature. After this, there we go. That's fine. We can set it up more correct later on. Then this we're still gonna keep as is. We're still gonna call it load assets. That's fine. But that what we can do now is inside our application itself. We already create that. We can bind shader with shader.get. Right? And then after that, we can call load assets. And that should all work. Only issue is we need to keep this alive. So inside here for now, we're just gonna do HB unique pointer of shader. shader. There we go. I do think we need a shader defined here. There we go, like so. And then inside our application.cpp, we can just say mshader. And if this all compiles, I think we should still have a triangle, but now we have a shader. Oh, of course it doesn't. Okay. Got some errors over here. Let's see. Okay, so we do struct. No, that should be class. There we go. X12 shader. Let's do first. That should also be class. Okay. X12 unique pointer, or there's no acceptable conversion. Oh, is this not a const function? Oh, that might be an issue. Okay. No const it is. Fine. Well, layout can be const actually. Like so. But that does mean that we can't do const on the render API though. If we do bind, I don't think we can do const. Unfortunate, but sure enough it will work. Boom, boom, boom. That's all done. And I think now it should compile, or maybe I forgot something else. It was pretty good. It's format that's failing? Why is format failing? I think I know why. What's the issue with the format? Cannot format to make type format. File path? Okay. Data. Fine, that's stupid. Why is that not just standardly implemented? You give me a standard string, and then you don't make the word format. Oh, something else wrong? Some good water. What? Huh? Standard format with string. Huh? What the actual, huh? Oh, it probably needs white strings, maybe? No, I do need to work. Okay, no file path, it is good enough. This will work then. I mean, it's a small thing, we don't really need it. Compile. If that's the only error left, we will see it compile fully, and then we can add... Wait, what was that weird one in here? Wait, hold on. What project? What the hell is that? Following a street, there's an error. While compiling, no destructor called for shader. I don't need it. Application.cpp. I don't include shader. Okay. Shader. Wait. Did application helpers. And 32 application helpers, and then X12 application helpers should do that, and that should include shader. That should work perfectly fine. Default. How does it work for window? Does this have a delete destructor? No, it's default as well. Oh, yeah. We need to shader it with no pointer. And then poop. Should it work now? That would be nice. No? Huh? While compiling class, see the reference of that, see that. While compiling, no pointer, see the first blah blah blah. See reference to template shader being compiled. Deletion of pointer to incomplete type, no destructor called. But it's not incomplete. This has it specified. How did I cast it? No. Huh? It's the exact same thing. Do I not have, oh, or does this include like, this is gonna include the window and it's the only way it works, isn't it? Does this include the window? But this also includes shader. Also, this should be at the top. I don't get it. We do the exact same thing. Huh? We do that. And then we create one with the equals. This will fill it in like so. Yeah. The create shader, which will create a unique pointer of DirectX 12 shader with a file path, which will pass it along to this one. Window has the same thing. This is virtual. Has the same constructor though. So maybe that should be the issue. I don't think that's the issue, but sure. I don't think that's the issue, but sure. No, it shouldn't be an issue. I don't get this. What is this error even saying? How can you, it should be in there. Unique point. You go here, yeah, from the reset, because call that. Oh, should I just do shader? I don't know why window is needed, but shader isn't. Maybe already in here? No, right? No. Yeah, that makes sense. I don't know why it's grayed out. Probably because it's already in render API, but oh well. This should work now. Okay, let's see if we still got our triangle. I mean, there might be some issues here. Oh, yep, we got some issues here. There's an exception. Axis reading location, which is great. Vertex shader is no pointer. Oh, I didn't call load on the thing. Okay, yeah. So, application, small fix, really easy fix. You know how I just made a shader here now? We also need to load the shader. There we go. Now it should work. The stupid mistakes we make sometimes. Yes, okay. So we got this now, but we got it with a shader class. Even though it's basic, and I still need to figure out how to do it for multiple shaders at one time. Because what if we have two different things with different shaders? Yeah, right. Nobody knows yet. Whew, okay, next thing, let's also add a mesh, I think. So, how are we gonna do this? We need a mesh class. Okay. Let's go back to our render API. So, can we actually throw something away from here yet? Almost, we can almost throw away this. Shader, I don't know if we need shader still. Oh, we still need it for this. Okay, bind shader, yeah. And then, do we have... We don't have aim shader in here, but that's fine. We still need to get rid of all of this stuff. Vertex buffer, view, vertex buffer. Oh my god, we still need to get rid of so much stuff in here. Oh boy. I don't like any of this. Right, we need to make a fence, we need app resources. I still don't know, where are we actually using this? This might be end up in the mesh class, actually. So let's see, where's the vertex buffer? Used. Vertex buffer, okay. So that's what we're gonna use in a second. So if we make a mesh, don't know where the vertex buffer is actually filled in. It's here, right? Alright, so this is where we fill in the triangle and the resource. So this is what we're all gonna do, right? This will be all in the mesh. This is all the mesh data. This whole block. We don't even have indices at the moment. Wow. Huh. Interesting. Oh yeah, it's just a triangle list at the moment. Okay. Interesting. What did we already do today? Not that much now. Yeah. So what is mesh but just a list of vertices, right? We're gonna have to set it up properly though. It's gonna be difficult to do. Yeah. Okay. Oh boy, I really need to set this up properly, don't I? I need to do some research on this. I don't think I can actually do it. We also still need to fix this. There's so much to fix. But we have our shader now. Even though it's a basic version, we got our vertex already here as well. I think next thing we need to do is make a mesh class. But I think I'm tired. I'm way too warm. My water is almost empty. It was a fun stream. I'm gonna say that. It was a lot of talking today. Not as much progress as I wanted, but every single time I'm like in a weekend I think like, okay, I need to prepare my next stream. And I look at this list and it's like, hey, I already prepared it. But then I get into it and it's like, okay, so basically this we did. We need a mesh class. Mesh. We need to figure out how to properly set up. Actually, let's do the planning now so I can look all of this thing up. Properly set up BSO. What do we also need to do? I think that's it at the moment. And then we also need to fix all of these things, right? How are we gonna actually do it? Some questions here as well. I think at this point I just need a lot more research. And I'm not gonna bore you with that on stream. I think we've had enough documentation for now. I did learn a lot though. Learning about how to properly use all of the other things. But so let's just do one final thing, which is get all of these commits in. How are we gonna call it? Basic shader implementation. Class. Let's do that. Commit and push. And push it. There we go. Okay, that's all finished. Oh boy. Okay, it was a fun stream. Done. Okay, great. We got a lot more to do. But I think at this point it's just a lot more of me researching things, which I will do off camera, and then make a lot more detailed notes, and then next week we can start implementing this. I still hold myself to the standard of I'm not gonna program off camera. I don't know how long I'll be able to keep that up, because every time I'm itching like, oh, I want to start working on this, I want to actually finish this. I want to move on from graphics programming as fast as possible. I've reached my limit and we only have a triangle. Oh boy. Anyway, I think that's gonna be it for the stream. If you liked it, just remember, I do this every week, every time, same time. So I'll be here next week, 8 p.m. again. There should be a scheduled stream. The stream should be scheduled somewhere in the weekend, so you can look out for that and put in your calendar. Other than that, I did update my description on the stream, but I'll do it off camera as well. So my GitHub is in there as well, and my personal Discord as well. So if you're interested in that, want to see more of me, you can check out those couple of things. Other than that, I said it like 5 times now. I think that's it. Let me just find the end stream button again. I hope I have a wonderful rest of the day, rest of the week, and I'll see you next week. Goodbye. I clicked the button.